Now, today we'll be talking about how to identify a normal ECG. So, today's topic is all about normal ECG. Now, to call it as normal, everything should be normal. What is everything? All P wave should be normal, all QRS should be normal, all T wave should be normal. Now, there are other things like there is PPR segment, then there is ST segment. This should be normal. So, in short, what should be the P? We must know that P wave means it is atrial contraction. This much only you should know. Now, the P wave should be less than 2.5 small boxes tall and less than 2.5 small boxes wide. So if it is there, and it should be positive in almost all the leads. If this satisfies all the criteria, all the P waves are normal. Now let us see. So we know this is P, this is P, this is P. So this P is positive. Why positive? Because this is the baseline. This is the running baseline. Okay. This is the running baseline. This is the running baseline. So if this is above the baseline, we call it as positive. If it is below the baseline, so this is above, so it is positive. If it is below, it is negative. So all P should be positive. Just see here, the P is positive, so it is positive. It is positive. Here it is negative, but see, the QRS is also negative. And in AVR, only in AVR and V1, you can expect P to be negative. But in most lead, it should be positive. Here it is positive, positive. It is positive, positive, positive. So in all the leads, it is positive. So it's okay. This is a normal P wave. What are the things? It should be 2.5 small square, tall as well as wide. It should take less than 2.5 small boxes. See here, it is 1 and 2. Everywhere it is less than 2.5. See here. So there is 1 and 2. So here it is one small box and two small box. One small box and two small box. Here it is one small box and two small box. So everywhere it is two small boxes. So here it is one small and two small. So in short, P wave should be positive and should be less than 2.5 small boxes tall or wide. So this is all normal P waves. So this ECG has all the normal P waves. What is next is QRS complexes. Now, what about QRS complexes? QRS complex should be very tight or sharp, and this QRS should be less than two small boxes, preferably narrow. Up to 2.5 small boxes, it is still acceptable. So you can simply remember that even if it is P or QRS, it should be less than 2.5 small boxes. So here, and all the QRS should look like same. The same goes with P wave. All the P waves, they should more or less look like same. So here it is one and a half small box, one and a half small box, one and a half small box, one and half small box, one and two. So up to two small boxes. These are all two small boxes. And these all QRS, they look like more or like same. What I want to say by more or like same, in any particular lead, suppose in V3, all the QRS should look like same. V3 QRS and AVR, they can be different, but in any particular leads, all the QRS should look like same. So in V6, they all are same. In V4, they all are same. So that is what we are talking about. So less than 2.5 millimeter wide, and this is perfectly normal. One more thing which you must remember for QRS is QRS, they should have a typical pattern. When we see V1 to V6, in V1 and V2, means when we start from here, the QR is very less and S is more. So you can see R is only 3 to 4 and S is almost 10, 12 millimeters. Same with V2. The R is not at all there and S is prominent. So this is typical pattern that in V1 and V2 you can see. In V3 and V4, it is in the middle, so R should be around equal to S. So here it is around 4 to 5, here it is around 6, 7. Here it is around 6, here it is around 6. So V3, V4, R wave should be as equal as S wave. So it is perfectly fine. And V4, 5 and V6, R should be much more than S. So exactly reverse of V1 and V2. So here it is all R, S is very small, R is tall, S is not there. So it is perfectly fine. So this is what we call it as R wave progression. So we should get this type of R wave progression, then that is a normal QRS pattern. Next thing we have to see T waves. Now T wave is very, very important because T wave is a repolarization wave and T should be normal, means it should be positive in almost all the leads. So here this is the T wave, this is the T, so this is P, this is Q is the first negative wave. Here we are not seeing Q negative wave, so you can forget there is no Q wave. R is the first positive wave after P, and S is the first negative wave after the R wave. So this is P, this is R, this is S, and this the next thing is T. So this is T wave. T should be positive in all leads. What do you mean by positive? Again, this is the baseline. So above the baseline is positive, below the baseline is negative. See, here it is negative, but in AVR or V1, it is perfectly fine to have a negative T wave. See, V3 positive. What about V4? V4 positive, positive, positive. So in almost all the leads in AVL, it is positive. Here it is positive. Here it is positive. Here it is positive. So positive T wave in almost all lead is very significantly normal. If T is negative in persistent 3, 4 leads or in consecutive leads, it definitely suggests abnormality. And now we are talking only about normal ECG. So this is a normal T wave. So this is normal P wave, normal QRS, normal T wave. Now what about PR segment? PR segment, we call it as prolonged P if the PR duration is more than 20 milliseconds. Uh, so what you need to see, yeah, this transform into total 5 small boxes. So from starting of P to the R wave, there should be less than 5 small boxes. So just see here. So this is P wave. So there is one box, two box, three box. There is the one box. This is one box, two, and hardly two and a half. Here, one box, two, three. So three boxes. Here it is starting of P, one box, two box, three. So this is a normal PR segment or normal PR interval. So basically, there is no prolongation, so it omits actually any block, especially first degree heart block or second degree heart block. So this is a normal PR segment or normal PR interval that we can see. The next part is ST segment. So what is ST segment? Most of the time ST segment is used to determine STEMI or non-STEMI, matlab MI, that is for heart attack. So if you want to label any heart attack, whenever we want to label a heart attack, we have to label it as ST elevation MI or non-ST elevation MI. So what is MI is heart attack. Elevation is you have to see the elevation of ST segment. So there can be ST segment elevation or there may not be. So ST, to call it as ST segment elevation, we need to find the S and T. So here this is S wave and this is T. So this is positive. This is coming to the baseline and then This is baseline, then this is T wave. So there is no ST segment elevation at all. Here you can maybe think of some ST elevation here, because the S segment will not come up to this. If the patient has MI, suppose here it will be like R wave, S will come to this only, and there will be T wave. So this will look like this. So this is the baseline, and now you can see that the patient will have ST elevation of 1 box, 2 box, 3 box. So a 3 millimeter ST elevation. So this will be like heart attack. I'll explain this again. Suppose if there would have been a MI, so in any segment, this is R wave, this is S, but this will not fall to baseline. It will come to some level, maybe up to here, it will come like this, or maybe it will be like this, or maybe it will be like this, but it will be definitely above the baseline. So this will, we call it as ST elevation MI, because T and S, they will merge and they'll form a elevation. Same way, if there is ST depression, you will have a changes like this. You will have changes like ST, and it will be like this. So there will be depression. If this is baseline, so there will, the patient will have depression of 2 millimeter or 3. More than 2 millimeter in chest leads. What is chest lead? V1 to V6 is, we call it as chest lead, and this all other leads, 6 leads, we call it as limb leads. So we look for this ST changes. So in this particular ECG, P waves are normal, QRS they are normal, PR interval or segment is normal, and the ST segment is normal. So and one more thing, this is perfectly regular. The heart rate is constant. So just see that in between the two R, so from here to here, how many boxes we have? There is 1 box, 2 box, 3, and around 3.5. Same here, 1 box, 2 box, 3 box, and 3.5. Large boxes, 1 box, 2 box, 3 box, and half. So there are constantly around 3.5 large boxes in between the in between the RR. So heart rate is constant, and heart rate between 60 to 100 should be acceptable. If it is less than 60, we label it as sinus bradycardia. If it is more than 100, we label it as sinus or tachycardia. So how to calculate heart rate is very easy. Take 300 divided by number of large squares. So here it is around 3.5. So for easy calculation, we'll only take 3 boxes. So the heart rate is around 100. You can calculate the same thing by 1500 divided by large square. So large squares will be around 18. So it will be still less than 100 and more than 60. So if there are only 2 boxes in between the R, so 300 divided by 2, so the heart rate will be around 150. So overall, this is perfectly normal ECG with normal P wave, normal QRS wave, normal T wave, normal PR, and normal ST. So this is a normal ECG. I'll show you some few more examples of normal ECG. Thank you.